Yash Shukla. He is Executive Director at Center for Advanced Research in Building Science and Energy. He has more than 15 years of international experience in building energy efficiency research and serves as a lead on several energy efficiency research projects at CARBSE. His current research includes calibration of simulation models, performance characterization of envelope and HVAC systems, net zero energy buildings, and development of next generation control algorithms. Mr. Shukla will deliberate upon natural ventilation. So delegates, let's welcome Mr. Yash.
So I'm going to talk about a little bit about the natural ventilation strategies for tropical buildings. Before I start, I want to acknowledge support from this research project, Low Energy Cooling and Ventilation for Indian Residences. So all that I'm talking about is part of a research project that was funded, and then the research by Loughborough University and Suffolk University. And we had wonderful partners, including ISHRE, who helped us develop these guidelines in natural ventilation. What Vaibhav talked about, what Vishal talked about, I'm trying to put it in one sort of simple image, is that to achieve a healthy and comfortable buildings, we actually need multiple wheels, cogs working together. If you can imagine that if one of these wheels falls away, then you would not achieve your ultimate aim. So you would need good ventilation, so you can increase the outdoor air quantity supported by passive or active filtration. You need periodic cleaning and maintenance, and at the same time, you also need a good air distribution system and air movement. So achieving all these 5 components are very, very important to achieve comfortable and healthy buildings. Now, what I'm going to talk about is a combined use of natural ventilation and mechanical cooling in buildings. So we can have different ways of increasing outdoor air quantity or air exchange rate, ACH, as Vishal explained. I'm going to focus on one of that technique, which is called natural ventilation. Now, there are different ways of achieving natural ventilation. Natural ventilation can be achieved by, a regular windows, where you can design your windows or a purposely provided openings. We call it PPO. I remember you might have remembered in your, in your some historical building visits, in temples, in some of the forts, that there would be some openings on the top end of the buildings which were naturally ventilated. So that design was mimicked, created to allow natural ventilation in the room. Now, in the modern context, what we need to look at is a more sophisticated approach of mixed mode building design. Because as the climate gets more and more extreme, we may not be able to provide comfortable environment just with natural ventilation. At the same time, if we use air conditioning system 24/7, then we will be spending tremendous amount of energy and increasing the burden on our grid and on our country in general. So that's why a good combination or use of natural ventilation and outside is comfortable, and we have a good quality air. And mind you, while we talk about indoor air quality, there are times in outdoor air quality. There are times in the year when the outdoor air quality is extremely bad, but there are times of the year and times of the day where the indoor-outdoor air quality is something that you can work. So you need to utilize and find out what is the period of the year where you can use natural ventilation, and then use different strategies. So in this slide, I'm talking about a couple of strategies. So you can use a strategy which on a cool day where you use only a natural ventilation and zone your building. So certain part of your building operates in a natural ventilation, while the other part operates in a air conditioning mode. That's called zone mixed mode buildings. Or you can do a temporal mixed mode, which is on the right, 2 images on the right side. So when outside is comfortable, you use the air to provide the ventilation, outside air. If you use a mechanical system to utilize that outside air, comfortable air, then it's called free cooling. So you can utilize that either through the fan, which becomes a mechanical ventilation, or a free cooling, or you can use a window or purposely provided opening, as it's seen on the bottom image on the right side, to provide to get the outside air in the building. And when it gets extreme, which often it does in many cities of India, can turn off those openings and you rely on the air conditioning systems to provide comfortable air. You can do a concurrent mix mode, which is on the top first image, but that's very rare unless you have a temperate climate. So to explain you a little bit more about how one goes about designing the natural ventilation, I'm going to talk about 4 or 5 slides. So we did, as a part of the research, we analyzed many cities in India and analyzed the climatic data. And from that data, you can see we came up with this image for 8 cities and what operation mode the building has to operate to provide comfortable environment. And the orange part in the bar in the bottom represents the time of the year when building can operate in natural ventilation. And you can see here in many cities, even extreme cities, very humid cities like Chennai, Mumbai, and Kolkata, you can operate your building 10 to 15% of the hours, while in cities like Hyderabad, where you have a more diurnal variation, you can operate 25-30% of your year in natural ventilation. So this slide essentially shows that there is a good potential to use natural ventilation in different buildings in India. Now, how do we go about designing these openings? It's very important to design what should be an area, because in natural ventilation, the area, not the flow, decides how much air you're going to get in. And of course, it depends on many factors, but if you have a good opening design, good orientation, good well-planned opening location, you would actually be able to utilize the air much better. So this is a design chart that we prepared as part of our research, where on x-axis defines what's the airflow rate that we need for different cities and what's the opening area you need to achieve that. And what you see in the dotted line is an opening area that we typically see in residences in India. So in Mumbai, Ahmedabad, and Delhi, this is the typical 2-bedroom hall kitchen apartment would have as an opening area. But to effectively utilize natural ventilation, on the right side, the solid red line is what you see is the opening area you need. So you actually need to start increasing the opening area and locate it at the right place. So there is a design chart that has been developed to help people design the opening areas. Once you know the opening areas, you need to select the type of windows or doors or the PPOs, like I said. And it's also important to remember what kind of windows do you use. If you use a sash window, you can only use half of your window. But if you are using a casement window, you'll be able to utilize whole opening area of your window. So that design strategy can be easily incorporated by selecting the right kind of window and right kind of opening area. Now, I know it's a very little time to talk about natural ventilation, but you can go and we have a design guide that's available on our website. You can register yourself, it's free of cost, download and know more about how natural ventilations can be used in buildings, what can be done to do it better, what are the calculation methods, the formulas, and that way try to design a mix for buildings. With that, I hand it over back to Krishna.